আজকে আমরা করব ফার্স্ট অর্ডার পার্শিয়াল ডিফারেনশিয়াল ইকুয়েশন। পার্শিয়াল ডিফারেনশিয়াল ইকুয়েশন পিডি। আচ্ছা, আমরা যদি z ইকুয়ালস টু এফ z ইজ এ ফাংশন অফ সিঙ্গেল ভ্যারিয়েবল x যদি হয়, if z is a function of fx, then z is functions of single variable x. In this case, x is independent variable and z is dependent variable. Z depends on x. Then we can make ordinary differentiation, that is ddx of z f dash x. But if z is function of more than one independent variable, say two independent variable x and y, z is a functions of two independent variable x and y, then we cannot make ordinary differentiation because we cannot make differentiate z ordinary. In this case, we differentiate z partially. Partially means, since here two variables, independent variables x and y, so if we differentiate z with respect to x, then we have to take y as constant. Again, if we differentiate z with respect to y, then we have to treat x as constant. Then when we differentiate z with respect to x, keeping y constant, the symbol is not d, del x of z, del z, del x. In this case, we differentiate z with respect to x, taking x as variable but y as constant. And del z, del y, partially derivative differentiation of z with respect to y. In this case, we have to take x as constant. Generally, del z, del x is denoted by small alphabet p, and del z, del y is denoted by q. Then the function consisting of two independent variables, two or more independent variables x and y, z's dependent variable, z depends on x and y, and the first order partial derivative of z with respect to x, that is p, and the first order partial derivative of z with respect to y, that is q. Consisting of these variables, the relations or functions is called a partial differential equations of first order partial differential equations. Now, today we learn how to construct or formulate a partial differential equations by eliminating arbitrary constants and by eliminating arbitrary functions. We have to eliminate when arbitrary constants are given. There is given a relations between x, y, z and arbitrary constant, one or more arbitrary constant. Now we have to eliminate arbitrary constants to form relations between x, y, z and p, q. These are the again, if there are arbitrary functions, then we have to eliminate arbitrary functions. That is to construct a partial differential equations. And second part is solutions of partial differential equation, first order partial differential equations by the method of Lagrange method, auxiliary equation. So now we have to study how to construct a partial differential equations from ordinary equation. Let us take example. Suppose z equal to x plus a into y plus b. Z equal to x plus a into y plus b. Here a and b are arbitrary constants. We have to eliminate arbitrary constants and to formulate a partial differential equations. So this number one. Now we have to differentiate z partially with respect to x and y respectively. If we differentiate z with respect to x, then del z del x, this is equal to x is variable. This terms variable. This is constant. This is constant. This is constant. Then this will remain same. Y plus b into derivative of this with respect to x. Derivative of x is 1 and derivative of a is 0. A is constant, so its derivative is 0. So del z del x equals to y plus b. Del z del x means del z del x we simply denote by small p. P equal to y plus b. Again, when we differentiate it with respect to y partially, then del z del y, this equals to, when we differentiate with respect to y, then we have to take x plus a as constant. This term is constant. Constant must remain, since it is as a product, so it remains x plus a into derivative of this. Derivative of this, derivative of y means 1, because with respect to y, and derivative of b is 0, that is 1. 1 means x plus a into 1 means x plus a. We denote del z del y by q. Q equal to x plus b. Now we have to eliminate x plus a. Now we have to eliminate a, b, c from these three relations. This relation, this relation, this relation. We have to eliminate from these three relations. So how to eliminate? If we find out a and b from these relations, and if we substitute this in this relation, then a and b will be eliminated. Then from this a equal to q minus x, and from this b equal to p minus y. Now substitute here. 1 substitute in 1. Then z equal to x plus a. A means q minus x. Q minus x. And y plus b. Y plus b. B means p minus y. P minus y. Then y cancel, x cancel. That is z equal to pq. There is no arbitrary constant. This is the partial differential equations. Formulations complete, because it contains z, p and q. Z, p and q. So this is partially differential equation. We have eliminated a and b. Now another problem. Problem 2. 2z equal to ax plus y whole square plus b. Here arbitrary constant is a and b. We have to eliminate this arbitrary constant. So we first differentiate partially with respect to x and then y. If we differentiate it partially with respect to x, then 2 del z del x, that means p. Del z del x, that means p. We get del z del x p equal to, if we differentiate taking as single variables, that square functions, it will be 2ax plus b into differentiation of this with respect to x. Differentiation this with respect into if we differentiate this, then a into x, differentiation of x is 1, derivative of x is 1. So a and derivative of y is 0, because we differentiate partially with respect to x. So keeping y constant, we must take y as constant. So it will be a, and derivative of b is 0 because it's constant. Then this equals to this. 2 cancel. Then p by a equal to ax plus b. Number 1. This is number 2. Again, if we differentiate this with respect to y, then it will be 2 del z del y. Del z del y means q. Del z del y means q. Now it is square functions, so it will be 2ax plus b. Now we have to differentiate this ax plus y with respect to y partially. With respect to y means derivative of ax is 0 because x constant. We have to take x as constant because we are differentiating with respect to y. We are differentiating partially with respect to y. So we have to take x as constant. So when we differentiate this with respect to y, this is constant 0 plus derivative of y partial derivative equal to 1. তার মানে 0 plus 1, that is 1. 2 to cancel, then q equal to ax plus b. Now we have to eliminate, this is 3. We have to eliminate a and b from these three relations 1, 2, 3. If we observe this and this, then we see that ax plus b, same. Then p by a equal to q, p by a equal to q, ax plus b equal. Then p by a equal to q. So we can write p by a equal to q. From this, p equal to aq. From this, a equal to p by q. So we have found a equal to p by q. Again from 1 and 3. 1 and 3. From 1 and 3, we can substitute the value of ax plus b, that is q, in here. So 2z equals to q square plus b. From this, we have found that b equal to 2z minus q square. So a equal to this and b equal to this. We have found a and b. Now we have to put the value of a and b in equation 1. 1. We have to put this in equation 1. 2z equal to ax plus y. ax plus y. A means p by q. p by q x plus y whole square plus b means 2z minus q square. 2z minus q square. Then from here 2z cancel. Take q square minus q square. If you bring it left, then it will be q square. Q square equals to px plus LCM taking qy whole square by LCM q square. That is q square q power 4. Q power 4 equals to px plus qy whole square. There is no arbitrary constant consisting of this relation x, y, p, q. X, y, p, q. This is the partial differential equation. This is the required partial differential equation. Now, another problem. Problem 3. ax square plus by square plus z square equal to 1. ax square plus by square plus z square equal to 1. Again, we have to differentiate this partially with respect to x and y. When we differentiate it partially, this with respect to x, this will be a into what? 2x. Then it will be 2ax. And partially derivative differentiations of by square 0, because when we differentiate with respect to x, then y, we have to take y as constant. Then by square 0, it will be 0. And differentiation of z square function 2z and derivative of z del x equal to 0. That is 2 common ax plus zp. Del z del x means p 0. So 2 0 0 by 2, that means 0. So ax plus zp equal to 0. This is number 2. When we differentiate this partially with respect to y, then this term will be constant. That is, this term will be 0. Plus by square, derivative by square 2by, y square derivative of y square 2y, and z square, square function 2z, and differentiation of z with respect to y means q. Del z del y, del z del y, del z del y means q. Just to write q equal to derivative of 1 is 0. From this 2 common, by plus zq equal to 0. If we divide by 2 here, 2, this will be 0, that is 0. This is number 3. Number 3. Now we have to eliminate a and b from 1, 2 and 3. How to eliminate? From 2. We can get from here a equal to minus zp by x. We can get b from here minus zq by y. Now we substitute the value of a and b in 1. A in 1, the 1 in case of a we write here. This zp by x into x square, and b means zq by y into y square plus z square equals to 1. X cancel, 1x, 1y cancel. Then it will be minus, take common as zpx minus zq y plus z square equal to 1. Multiplying by negative minus 1 both sides, then it will be zpx plus zqy minus z square equals to minus 1. Then it will be z, take common, px plus qy equal to z square minus 1. This is required differential equation. This is required differential equations. So constructions of arbitrary differential, partial differential equations by eliminating arbitrary constants. Now we have to construct partial differential equations by eliminating arbitrary functions. When arbitrary functions are given, arbitrary function. Take an example. Example, z equal to xy plus function of x square plus y square. Here f is arbitrary function. We have to eliminate f. F is arbitrary function. So first we take f of x square plus y square. This x square plus y square equal to u. Let u equal to x square plus y square. Then we can write z equal to xy plus function of u. U contains x and y both. So now we have to differentiate with partially with respect to x and y. With respect to x, take this as 1. When we differentiate this partially with respect to x, then del z del x, del z del x. Partially with respect to x, then y constant. Constant means y into derivative of x is 1. That is y, only y. And from here, if is a function of u, f is a function of u, u is function of x and y. When we differentiate f with respect to x, partially differentiating with respect to x, a with respect to x, then we have to make differentiate a with respect to u, then differentiate u with respect to x. Differentiate a partially with respect to u, then differentiate u with respect to x. This will be del f del x. So when we make differentiate with respect to x, then it will be del f. First differentiate f with respect to u, del f del u into u is a function of xy. u is a function of xy. So when we differentiate u with respect to x, it will be partial because u is a function of two variables. Then del u del x. Okay. Then we can write del z del x as p equals to y plus del f del u and del u del x means from here del u del x equal to 2x. This is constant 2x. This is number. We can write this from here p minus y equals to del f del u into 2x. This is number 2. Now we differentiate this partially with respect to y. This is partially with respect to x, partially with respect to y. When we differentiate partially y, then del z del y. Del z del y means we write directly q. And partially differentiate with respect to y variable x constant. Then constant into derivative of y 1 x. And it will be partial derivative with respect to u with respect to x, with the f derivative of f with respect to y. Sorry, derivative of x with respect to y means del f del u into del u del y. Del f del u into del u del y. This means q minus x equals to del f del u into del u del y means u equals to x square plus y square del u del y, this constant 0 plus 2y, that is 2y. This is number 3. Now we divide 2 by 3, then del f del u will be cancelled, arbitrary function eliminate, then divide 2 divide 3, p minus y divide q minus x equal to del f del u cancel 2x by 2y 2 cancel x by y. Now cross multiply py minus y square equals to qx minus x square. We can write from here py minus x square, py minus qx equal to y square minus x square. This is the required partial differential equation. There is no arbitrary function. This is one example. Eliminations of arbitrary function and constructions of partial differential equation. Now take another example. If x square plus y square plus z square, comma, z square minus 2xy equal to 0. This is relation given here, arbitrary function f. We have to eliminate f. So, how to eliminate? So, we have to take this as u and this as v. So, let u equal to x square plus y square plus z square and v equals to z square minus 2xy. Then this function becomes f u v equal to 0. So, f is a function of u and v. So, f is a function of u and v. U is a function of x, y and z. Okay? U is a function of x, y, z. And so u is a function of x, y, z. V is also functions of x, y, z. So v function of x, v functions of y, v functions of z. V is a function of z. When we differentiate f with respect to x, then partially, when you differentiate f partially with respect to x, then it will be, first f is a function of u and v. So we first partially differentiate f with respect to u. Del f, we have to find out del f, differentiate f with respect to x. Then del f del u, del u del x. Del f del v, del v del x. How we can reach from f to x? F to x, this path and this path. So this will be del f del u del x. Del f del v del x. Then it will be del f del u del x plus del f del v del x equal to 0. Del f del u del x, del f del v del x equals to 0. This equivalent to del f del x, del u del x, del u del x. This is from here. Del u del x, how? Del u del x, x square, derivative of x square means 2x. Y square derivative means 0 because partial derivative with respect to x, we have to take y as constant. And z is a function of xy because z is a dependent variable, depends on x and y. So we have to find out the derivative z square. Z square means 2z into del z del x. Del z del x. Derivative of z square 2z del z. Del z del x means p. Next step we write p. And del f del v into del v del x. Del v del x where? Del v del x. Del v del x means z square. Z contains x and y. Z is a function of x and y. So it will be 2z del x minus partially with respect to x, derivative of x is 1 and 2 and y constant minus 2y equal to 0. Equal to 0. So this is partially derivative with respect to x. We can write this del f del x from here. If we take 2 as common, then it will be x plus z p. This is p, del z del x p. From this, del f del v, if we take 2 common, z p minus y, this is p, equal to 0. 2 common, 2 we can take 2 as common and divide by 2, it will be 0. So write this only. This is. Okay. So this is the relation. This number 2. Again, we have to differentiate this with respect to y. With respect to y. With respect to y. Then it will be with respect to y. Y means del f del u del y. Del f del u del y. Del f del v del y. Del f del u del y. Del f del v del y. So del f del u del y plus del f del v del y equal to 0. From here, del f del u del y means 2y, f 2y, this is 0, and this is 2z del y with respect to y, and del f del v and del v del y with respect to y, that means 2z del z del y minus 2xy. 2xy means y with respect to y, 2x constant. 2x, y derivative of y is 1, so equal to 0. So from here we can take 2 common, 2 cancel because 0 here. So we write del f del u y plus z q, del z del m is del f del v z q minus x equal to 0. Number 3. Now we have to eliminate f. Now we can divide this by this. Then this will be cancelled and this will be cancelled. So we can get you can take this as del f del x x plus zp plus this, right, equal to minus del f del v zp minus y, and you can write this, sorry, del f del u y plus zq equal to minus del f del v zp, and it will be zq minus x. Now divide. Then if we divide, this will cancel, then it will be x plus zp by y plus zq equal to zp minus y divided by zq minus x. Now cross multiply this and get partial differential equation. You can write this here also. Then it will be now if we multiply, it will be xzq minus x square now plus z square pq minus xzp equal to, if we multiply this, yzp minus y square plus z square pq minus yzq, z square pq cancel. Then it will be xzq yzq. If we write here, then xz plus yzq, xzp minus, here it will be minus xzp, so minus xz plus yzp equal to minus x square, it will be plus x square minus y square. This is the required partial differential equation. This is the required partial differential equations by eliminating arbitrary constant. Okay? Today this will, next day we will do how to solve first order partial differential equations to get general solution. Okay?